So tonight we're going to talk about RxJS and we're going to talk about MobX. To have an idea about who we are, can you raise your hand if you know what RxJS is? Raise your hand. Wow, I like that. MobX? Yeah, okay, cool. But before jumping into the topic, it's time for introduction. I'll start with me. My name is Max, or Massimiliano, if you're Italian. If you're not Italian, I would suggest you to try spelling it. I'm principal engineer at DAZN, and if you're not gonna like the talk, you can come by after and talk with me about food, about technologies, about music, or about photography, typography. I have a broad range of interest if you really don't like this talk. You can find me on Twitter, _MaxGallo, and on maxgallo.io. But I'm not the only thing that I want to introduce tonight, because some of you may not know what MobX is. So I want that all of us, we're going to start from the same level. So what is MobX? From the first definition that you find if you go on the MobX GitHub repo, it says that MobX is a battle-test, simple and scalable state management library. And so we started to understand that MobX is already trying to solve a problem. What is the problem? Application state management. And this library is now 3 years old. It was firstly introduced in 2015 by Michel Westrate, and it's now getting more and more popular. And we're going to talk about which are the features and which are the core ideas behind it and what's actually inside it. RxJS, it's part of the ReactiveX family, which is something way bigger than RxJS. It's cross-language, so if you heard about RxJS only, be reminded that those are just concepts applied to JavaScript. Those kind of ideas are all over the world, but you raise a lot of hands, so I don't really need to explain you about this. What is it? I think the best explanation that I found was that it's an API for asynchronous programming with observable streams. It may feel a little bit complicated at the beginning, but at the end of the day, it's about asynchronous programming, dealing with asynchronous thing. After all this introduction, it's time to understand what we're going to do tonight. First of all, we're going to reinvent MobX. Second, we're going to reinvent RxJS. And at the end, we're going to see how the two of them play out together. But I want to let you understand why did I wrote reinventing. So this is a picture of me, 9 years old, with an awesome red train and an awesome shirt, by the way. And back at the time, I was exploring the world. I was curious about how things worked and how I was exploring it. For example, I remember a VHS recorder. It was broken, so I decided, oh, well, I'll have to see what's inside, how that works. So I was tearing things apart, literally. I'm not gonna lie, I wasn't able to put them back together every time. Sometimes I had things that I wasn't able to put them together. But it was my way, and I'm pretty sure someone else's way, to understand how things works from the inside. And tonight, we're gonna take the same concept and we're gonna go one step forward. So we're gonna see how it works, and we're going to reinvent the wheel. So we're gonna create a copy of that, our own copy, that we do understand without using a library that runs some magic inside. But we are going to grasp the concept. At least I hope that we're going to grasp those concepts. Let's start with MobX. Reinventing MobX. First of all, I want all to have a look at the code. It's important. I'm going to start from practical example. I want to be very practical, and I want to drive you to conclusion. So first of all, on top, we see that we are importing just two methods called observable and autorun, and then we are using observable straight away here is as a function. We have the first parameter, which is an object, and we are creating our const, which is OK Computer. If you're a fan of Radiohead, you know what I'm talking about. This observable here, it's gonna be used later on, but this is how we use the observable. It's just a function. Then we have autorun. Autorun is another function that accepts one parameter only and it is expecting a function. What is doing autorun is that, first of all, as soon as you write it, it's going to execute the function straight away. So immediately, we're going to get, this is a normal console log, okay, computer play count, and it prints how many play count I have on that album. As soon as I do the autorun, it's going to output, okay, computer play count 0 immediately. But that's not a really useful function. So autorun, on top of that, will rerun the function that I passed as a parameter every single time any observable in that function changes. You raised a couple of hands, so some of you may be familiar with this concept. The only thing to understand is that MobX is able to understand which are the observables here in this function and is somehow subscribing to them for changes and is going to rerun this function every single time we change something. Example here, okay, computer play count, I'm listening to the album twice, I'm gonna see, okay, computer play count 2. Okay, computer, no. Okay, computer play count 20, okay, computer play count 20. So as soon as I change something, and I'm changing not a normal object, bear in mind, this is the output of the observable, so something that MobX has under control. As soon as I change that, my autorun function immediately runs. First impressions are super important. The syntax is really close to the language. I didn't have to tell you how to do a setter and a getter. It doesn't have a weird interface. It doesn't have a special interface. It uses the language. The setter is with the dot notation. The getter is again with the dot notation. So if you are if you're interested in learning it, you don't need to learn much. Second, no explicit subscription. The autorun function is able to understand what's going on inside and which are the observable to subscribe to without me, developer, telling MobX what to subscribe to exactly. So it's actually MobX that is taking care of that part, which feels a little bit of magic. If you ask me, the first time that I saw it, it was like, wow, does it actually work? And the answer was yes. And this no explicit subscription has a proper terminology, which is transparent reactive programming. I don't want to talk too much in deep about reactive programming because this talk is all about reactive programming, but I want to focus on the transparent. When we do subscription, there is always the potential error for undersubscribe or oversubscribe, so to do less or to do more than enough. In this case, MobX is solving that problem because it's saying, okay, let me take care of that. I know which are the observable, I'll take care of that. I'll do the subscription. And this is why MobX is using a transparent reactive programming paradigm. Let's reinvent MobX. So we're going to start with some live coding. And I hope it's readable. Can you read it? Yes. Awesome. So this is the same example as before. I haven't changed anything. What we are going to do, on the left-hand side, there is my ID. On the right-hand side, there is just a node mon running, which is basically running my file every single time I change something. And if we go back here, what we're going to do is we're going to rewrite MobX. How we're going to do that? So first of all, we need to create our observable and our autorun. Boom, done. And as you can see on the right-hand side, everything is red. And why everything is red? Because this is not actually the real implementation. It's not even close to the real implementation. So I want to focus, first of all, to I want to focus on the observable. So for the observable, it's clear that something is happening every time I'm calling any getter and anytime I'm calling any setter. So somehow I need to wrap my, my object, my original object, the one with title, OK, computer, year 1997. I need to wrap that into something that I can intercept, because I need to get access to getters and setter, and then we can move on. In order to do that, whoops. So inside observable, this is my target object. I'm going to define another observable, which is going to be the outer one, which is observable object. And for the target, object keys, target object. So I want to get all the keys of my target object, and for each single key, this is object key, I want to do object.define property. And if you remember the syntax of define property, the first parameter is the object that I want to enhance with that I want to define the property into, which is observable object. And after that, there is the key of the object, so object T. And the third one is an object which contains a getter and a setter value. That's it, almost it. We are not getting it setting anything, so we should probably getting a setting anything. So target object dot object key. Remember, I'm using the target object, the one that I'm passing to getting data for data, but I'm wrapping it into something that I'm in control. So while setting, probably I need to return this, otherwise it's not going to work. And for the set, I'm going to do target object, object ID equal to value. All good. I just need to return the observable object. And as soon as I do that, hopefully, the code shouldn't crash. And instead, it's still crashing, because instead of calling object key, I called it object ID. So if we go on object ID, and we're going to change it to object key, yeah, it's green. I haven't done anything. Thank you. I haven't done anything. I just rewrote an object in a very complex way, and which is far from useful. But I can still, this is not working, but I can do stuff like sol log album1.playCount, and I hope to see 20. So at least I have a working object, very expensive and not expensive, expensive to write object, which I'm not really interested into. But let's leave it as it is. Now I have full control on getters and setters, and this is really important. An auto-run function. So we're going to call the parameters runner. The runner function, it's something that, as I told you before, the first thing that auto-run does is calling the auto-run function. So let's call the auto-run function. It's working. I have album1 play count 0 on the right-hand side. And what I'm not leveraging is that I'm calling that function without actually using it. I'm not leveraging that part. What I can do instead is to try to track all the observable properties that I access during the first run of the auto-run. And in order to do that, I need to create a variable here, global one, which is access the observables, which is an array. I need to make sure every time I do auto-run that my access observable is empty. And so once it's empty, I'm going to write it down after to console log. As you can see, this is an empty array because I didn't store anything into that array. But I have full control on the getter method here. So what I can do is I can do access observable dot push, and oops, what I'm going to push inside here, I need some kind of identifier for the object. And so let me create an helper function called get observable ID. And this get observable ID is going to return a unique initial part plus key. Sorry, I forgot to pass the key. And my unique part here is going to be a very safe and unique mat random. Safe. At this stage, I created my observable ID. Why is created in this way? First of all, because you need to have the unique part here, and it's unique per object, per observable. And the second part, the key instead here, is unique per key. So what I'm going to do is I'm going to use this function here. I'm going to push. I'm going to do get observable ID passing object key. Right now, as soon as I run it, we can see in the right-hand side that there is something here. So this is the list of all the observable properties I did access. And this is always good because I have that list. But what actually I'm going to do with that list? Because those are all the accessed observables. So I need to use those somehow. In order to use them, let me create another variable called derivation graph. You will understand in a second why this weird name. I'm not crazy, I promise. Derivation graph, it's something that we're going to use inside the auto run. So I'm running the function immediately. I get the list of all the things that I touched while running that function. What I'm going to do is I'm going to store for each of those accessed observable. This is object ID. I'm going to store inside my derivation graph. This is going to be a little bit verbose. Object ID equal derivation. Derivation graph, object ID, or this. Again, finally, to the interesting part, derivation graph, object ID, dot push. And I need to push my object ID here. So I'm building a graph, in this case a very simple graph. It's basically just a list with multiple nodes. I'm building it in a way that I can do the other way around. So the first time that I did run the auto run, I went for checking with all the observables that I touched. On the second run, instead, I want to make sure I know which are all the functions that needs to rerun every time I change my observable. It's the same path in two different ways, and we're going to see that how we can do it. Because at this point, I'm storing all I need, and what's happening is that I need to just update my setter method, because the setter method is the only place where we can change observables. So inside the setter methods, what I'm going to do is I'm going to get the derivation graph of get observable ID object key. This is get observable ID is the same thing that I was using here. Oops. I was using here because it is the same item. And I can do for each. This is my runner. And I can finally call runner. Hopefully, of course, it's not working because, sorry, 43 you said. I'm pushing the object ID, and you're perfectly right. I'm pushing the wrong thing. I need to push the runner. I need to push the list of functions that I'm accessing. So what we're doing here, and I promise no more code for this part, and what's happening is, again, I'm wrapping the observable inside around with something like a shell that I'm in control of. After I do that, I've got access to setters and getters, and after I did that, I can write a very simple autorun function that simply tracks all the items the first time and then stores a list of the runner functions that are going to be run for each single update, for each single mutation of my store. So we can see that this is working even if I'm going to create another album. So I can do album 2, probably not OK Computer, but in Rainbows, and I think it's 2006, 7, volunteer, 20. Perfect. So I created my second one. I create another auto run because I want to subscribe and to check if something is different. This is album 2, and I want to see album 2 changes. If I run this one, I'm gonna see album 2 play count here on the right, because this is part of the tracking. So I'm tracking what's going on, but we never change anything in album 2. As soon as I go and do album 2.play count equal to, thank you, Luca, album 2 play count. I didn't hear that. So as you can see, this is working fine. It's a fully working MobX observable and auto-run example. And this gives us a grasp of what's going on behind it. But let's try to recap what we just saw. First of all, MobX doesn't care about the past. Everything that we saw was about getters and setters. So unless we track down somehow in some other ways what's happening and like my history, MobX only cares about the immediate changes. So in the best case scenario, I can tell you, or MobX can tell you, which is the latest observable value and the current observable value, but nothing more. Act as a proxy in front of JavaScript. This is very important. In our case, it was literally in the middle between us developers and JavaScript. And what's happening is that inside, this is exactly how it works. Actually, in MobX 5, the latest implementation, is using ES6 proxy. So they do exactly the same thing, just with a native syntax. All reactions are synchronous. This is really, really important. The reactions are synchronous by the design, where you can read in an article that at the beginning of MobX, one of the requirements that the creator of MobX set for himself was like, I need to write something that is predictable. Imagine this applied to your React component or to anything. You want to know exactly, you want to have your stack trace that makes sense. You want to have a clear view of your changes or of your mutation. So all the reactions are fully synchronous, and I'm going to prove that. Not that there is the need for that, but if I do console log is sync here, this is going to be at the end, at the top, and these are all reactions inside auto-run function. So at the first sight, someone could tell, well, maybe they're going to run somewhere later on. Instead, no, I'm going to run all the reactions as soon as I can in synchronous fashion. Whoa. All reactions are synchronous. And last but not least, I mentioned the derivation graph. In order to talk about the derivation graph, I need to add a little bit of knowledge that I wasn't able to fit into the live coding, which are computer properties. If you know MobX, you know that computer properties, they play a very important role inside MobX itself. And if we need to describe them, computer properties are just derivation of the observable state. So you get a state property, and you can do something around it, or you can combine two of them. That's a computer property. In this case, our computer property, it's simply the concatenation of title and play count, and this is our computer property, and that's it, job done. The beauty of that is that the computer property is an observable as well, has the same interface. So I can use that inside the auto-run method in the same way I was using a proper observable. So we learned about observable, we learned about computer properties, which are derivation of the observable state. And we're going to see how these two play together in the derivation graph. So I want you to focus, first of all, on the creation flow. Creation flow is what we did at the beginning inside the auto run. So when we do the creation flow, we start from the reaction. As soon as we start from the reaction, we track down every single item that we touch under our way. And this is what we did. We were basically flagging, oh, I'm accessing this, I'm accessing this, I'm accessing this, and I was taking a list. And once we create this one, we start creating a proper derivation graph, which goes from reaction to observable values. And this, it's only run once. So we run it only a single time at the beginning. All the other time, we're going to run this, which instead is going from left to right. Because this time, this is one time, n time. These n times, I'm changing observable values. So what's happening is that I'm changing observable values, computer property get changed since they are a derivation of this state, and I'm going to run all the reactions that I have in the graph. This thing inside MobX is highly optimized, and that's why MobX can allow itself to be fully synchronous, because we do this thing for the creation on the left once, and we run the right-hand one every single time we update something. But all these connections here are highly optimized. If a connection is not available anymore, even if it's inside an if, which is at that end, MobX is fully capable of understanding that. And with this one, I will take a 30-second break before jumping into RxJS. I saw that you raised your hand for RxJS. How many of you wrote RxJS code in production? Okay, good, good, very well. I'm not going to show you anything for now, so like 20 seconds of silence, or at least we can breathe a little bit, because I promise there is some code, some other code, so I need to focus there, I need to concentrate it. So 30 seconds. And I need to drink something. Okay, I'm about to start. I hope your mind is super fresh now. I'm going to start really slowly, so if you want to grab some food, the drinks. So RxJS, again, the concept is to start with the code. I want to do the same flow. I want to start with saying a little piece of code. We are going to reinvent that, and we're going to see how that behaves inside. So if you're not familiar with this syntax, this is just Rx6 syntax, and we have a from that is coming from RxJS, and we have map and filter coming from RxJS operators. So we have three methods: from, map, and filter. How we are using those methods? So the from, we're using it immediately, accept one array as a parameter, and it's a method that will generate an observable that will start emitting all the values in the array. What's happening is that we are passing that array, and we are preparing, we are outputting an observable that I can consume later on. But before consuming it, I want to do something with it. I want to play around with it. So I'm using the pipe method, which is just syntax from RxJS. Well, not always RxJS, but in this case, yes. And then I'm using a bunch of RxJS operators to transform all the small events that are coming through the pipe. So I will have one at the beginning, so one will pass through map, will pass through filter, will pass through map again, then two, same, map, filter, map, then three, map, filter, map, and so on and so forth. The observable subscribe at the end that we have here is the way to consume those values. So what observable subscribe does, it's simply providing an interface to tell I'm ready to receive those values, those events. And how I'm doing that? I'm doing that by passing three functions. The first one is a function that is going to get called every single time I get a new value. The second one is a function that is going to be called every single time we have an error. And the last one, every time we completed all the events to emit. So here, after 1, 2, 3, 4, 5, after the 5, you will see completed. The output of this piece of code here is odd 1, odd 3, odd 5, and completed. This is simply a very not efficient way to filter out even numbers. Again, you start to understand the pattern. First impression. The syntax is library specific, or at least it's more library specific than the MobX one. With MobX, I was just using getters and setters. In this case, I introduced you the concept of piping, subscribing, the values piping down. So it's, I would say, more tied to the library. Explicit subscription. You remember when we talk about transparent reactive programming, that MobX was taking care of doing the subscription. In this case, it's up to us. It's up to the developer deciding, I want to subscribe to this, I want to subscribe to that. But it's really explicit. It's in the code. Bunch of things. Observable, it's something that right now I wrote that it's library specific, but right now is in TC31 stage 1. Which, if you don't know it, is a commission where we are laying the ground for the future of JavaScript, the new syntax. And observable, has been heavily inspired by RxJS observable, and they are in stage 1. So they make a change, of course, but they may also arrive to the language. So this light here, bless you, that is when syntax is library specific, it's true right now, but in 1 year time, we may have that this observable here is perfectly fine. It's not anymore library specific, it's language specific. And then that part will change. The other interesting part is the pipeline operator. That is on stage 1. That is on stage 1 as well. If you see the proposal, if I remember it correctly, is with the pipe and the greater than sign, and that's something that is coming probably more from the functional world, and it's something that could be in the language as well. So this code, which looks very RxJS oriented right now, in 1 year time, 2 years time, it could be plain JavaScript, something like getters and setters out as we were used to. Let's reinvent RxJS. So we are gonna go to RxJS. Same configuration, left-hand side we have the same code, right-hand side we have our old friends Nodemon. Just let me make sure that I'm running the right one. All good. So on the left-hand side, you know the format. We're going to destroy from map and filter, and we're going to rewrite function from initial data. Then I'm going to leave the operators for the second part. And inside here, we can use the map function filter, accept one parameter filter as well, which is the filter function. The first part is going to be slightly annoying because the syntax here is more verbose than MobX. So as soon as I save, everything is broken on the right-hand side. I'm going to build inside from what we need. I don't know why I'm leaving all those spaces, doesn't make any sense. So inside from, just following on this one, we need to return an object that contains pipe, and pipe is a function that accepts an arbitrary number of parameters, which are our pipe functions, which, again, if you see the pipe function, we are here now. And those pipe functions are returning an observable that I can subscribe to. So I need to, again, return another object which contains a subscribe method. That this time, this subscribe method has 3 values. Oh, probably I don't need the linter. Much better. Well, I definitely need the linter, but I'm brave enough to do it without. I'm going to regret this. And so return, we were saying subscribe method accept 3 parameters, these 3 functions here, and I'm going to call them on next, on error, and on complete. This is a function, and that's it. So at this stage, I have a very verbose from that potentially is not making my app crashing. So my app is green. I'm happy. It does nothing so far. And what I'm going to do is that I'm going to get a quick win. What's the quick win? Is calling the onComplete method. Completely useless, but it's a quick win. We already have something. We just need to do everything else. So onComplete is working. It's fine, I'm calling it directly. Now I want to focus on my data. Let's focus on the initial data, so our array 1 to 5. We need to start emitting those array data as soon as we subscribe. So whatever I'm going to do has to be here, has to be at this level, inside the subscribe method, not outside. If I do it outside, it's too early. So inside the subscribe method, allow me to create this kind of object, which is data observable. The name is data observable. With a subscribe method, I'm going to say subscribe to 2,000 times. I'm warning you. Subscribe method contains just one function, that one parameter that we're going to call inner on next. And as soon as we subscribe to this one, we are going to do initial data dot for each. So for each element of the array, I'm going to do inner on next. So I'm going to call this one. So far, we just created this part here. So we just created these 3 lines here. And you may asking yourself, why did I do that? Why can't I use directly the for each? There is a reason for that. We're going to arrive to that point. What I can do here, how I can consume this small inner observable is I can subscribe to it. So I can do data observable dot subscribe, and which is the function that I'm passing to the subscribe method? So the function that I'm passing to the subscribe method is inner on next, the one that is going to be called with each of the initial data. So the function that I'm passing here, on the subscribe is going to be called with 1, with 2, with 3, with 4, and with 5. But which is the function that I need to actually to be able to use here? Is exactly this one. Is the first parameter of the subscribe function. If you remember our subscribe function, our subscribe function has 3 values. The first one is the one that has to run for each single value. So it's a perfect fit. We can use this one, and I can do, where did it go? I can do data observable.subscribe, wait on next. As soon as I save, on the right-hand side, you will see that I have all the events. All the events are there, 1, 2, 3, 4, 5. I'm doing nothing, I'm not applying the operators. So this is good so far. I need to add a little bit more of abstraction here, just rewriting the data observable part. So I can write a function called createObservable, which accepts something that I call that we're going to call operator. This createObservable, right now, I want just to rewrite this one to being more flexible because I need to reuse this pattern later on. So what I'm doing here is I'm returning an object with subscribe method that contains inner on next that is going to call operator and operator of inner on next. So you can see that these and these are very similar. I just need to actually create it. So I can do const data observable equal to create observable. And which is my operator, which is the particular thing that I need to do in this case, is my function x initial data for each. And I'm not using direct initial scape initial data.forEach for scoping issue in this case. As soon as we save, we can see that everything is broken because initial data observable has already been declared, of course. So if we remove this one, this is still working. I haven't done anything. I just rewrote this part here into something reusable. So I can call this one passing a function that is going to be called every time we subscribe to the output. That's it. So I can get rid of this. I can keep this one and moving it outside so we can reusing it later. Why like this? And this is still going to work. Nothing changed so far. It's time to talk about operators, because this is not what we wanted. This is just the from without any piping, without any operators. We want to use the operators. So in order to think about the operators, we need to understand how the method inside pipe, how they works. First of all, there are operators. So it means that I don't know in advance how many of them I'm going to find. I don't know in advance which is my previous one, which is the next one. So I need to write something that has always the same interface to communicate with my previous operator and my next operator in order to being able to connect each other. So what we are going to do is having this kind of, I actually have a slide to explain this. RxJS operators are made of 3 parts: source observable, current observable, and next observable. What we're doing is that all these 3 parts, we're going to connect the next observable with the source observable of the next one. We are like chaining them. We are exactly creating a chain of previous, current, and next, previous, current, and next. And that will allow us to add an arbitrary number of them and to make sure that the values can go through. If we go back to this one and we start implementing the map function, we should, first of all, return a reference to the source observable. Once I have this, let me not forget this one. Once I have the source observable, what I need to do is create the current observable. How can I create a current observable? I just have a function called create observable. Inside the create observable, I have another function that has one parameter, parameter called destination next, and that means that I'm going to create that observable, and at the subscription of that observable, I'm going to do another subscription. So I'm going to do source observable dot subscribe value. So I'm finally playing around with the value here. And what I'm doing is that in this case, I'm passing, I need to map those values, so I need to use my function. So what I'm doing is I'm going to create my new value out of my old value. So I'm going to use my map function. And after this, I'm going to call destination next with my new value. I need to remember to return the current observable. And this hopefully will work. Well, it will not work because I'm not using them. So in order to make it work, I'm just going to filter out 1 second these two, just having one map. And once we have that, we need to do something smart here in order to use them. It's not really smart, but allow me to create a current observable here, which is the date observable at the beginning. So at the beginning, we start with the date observable. And then for each pipe function, we have pipe func. For each of the pipe function, what we're going to do is we're going to actually create that chain. So we're going to do that current observable is the pipe function of the current observable. And at the end, I'm subscribing to the current observable. So it's working. I'm going to recap a little bit slower, but I want you to focus on a couple of things. First one, chaining. Here, what we are doing is we are defining the current observable as the data observable, which is the part that we did at the beginning. It's just emitting 1, 2, 3, 4, 5, 6, not 6. And then what we are doing is for each of the pipe function, we are redefining the current observable. It's like we are moving the current observable one step further by applying my pipe function to the current position. In these ways, I'm going forward and forward and forward with an arbitrary number. I don't really care how many numbers we have. You start seeing why all those subscribes. Because I'm using subscribes everywhere, and that's the interface. That's the beauty of it. I can subscribe to small inner components, and I can chain them together, and I could bring you an output. In order to do that, I could do the same thing with the filter function. I'm just going to copy this because I think it was already long enough for you, all this live coding. But I want to stress out that just by changing these two lines, I can create my new operator. I can do, instead of this, I can say if actually filter function of value, if it's true, I should go to the next one. So I should call destination next with value. Just like this, I created a brand new operator out of the previous one. So if I put back filter and map, it's working. But why it's working? It's working because both map and filter, I want you to spend a little bit of time understanding here what's going on. This is the same as map. I'm going to use filter just because it's closer to my hand. So filter use source observable and is actually subscribing to the source observable to generate with this function, and is subscribing to the source observable when we subscribe to the current observable. So we are chaining each single pieces with the next one in order to have a complete, fully working stream. And this is, you can do that as much as you want. So I can add all the map function. This is perfectly still gonna work. You can see that I'm filtering things out. And how I'm doing this, it's by chaining those map and filter function. Promise, no more live coding for tonight. Sorry about all of this. This is very important, but let's draw some consideration. RxJS from the inside. First thing, I said the word subscribe like thousands of times because we are talking about reusable parts. We are talking about streams. We are talking about pieces that they work together inside, same as outside. This is roughly how it works. If you open RxJS code, you will see internally, you will see operators, you will see how operators chain together, how they subscribe to the previous one. And this is the beauty of it. Custom operators. I created one operator of my crappy RxJS implementation with 2 lines. But if you want to create a real one, a fully working one for the library, it's even simpler than the code that I show you. So you can go tomorrow, you can use RxJS, you can write your own custom operator, and that gives you a lot of flexibility. Lazy evaluation. All the subscribe methods are not just a way to chain things together, but are also a way to tell, I want this thing to start. Without the subscriber, nothing starts. Without subscribing to it, without explicitly saying, I want the values, nothing happens. Lazy evaluation. Offer a standard contract between parts. This is what makes the chaining possible. The standard contract, all the subscribe is a standard contract, allows me to use it from the outside, from the inside, and allows me to chain everything. Synchronous by default. Everything I show you, I'm not going to go to the code to demonstrate you, but it works synchronously. And in RxJS, it works synchronous by default. So you would say, well, similar to MobX, yes, but RxJS goes way further than that. It gives you the possibility to not only have a synchronous way of handling those events, but also the possibility to have different kind of asynchronicity. And how Rx is doing that through schedulers. Schedulers, from the definition of understalls, are the things that control the order of the event emission to observer and the speed of those event emission. And this is really powerful. We don't have that in MobX. We don't have that low-level control of that. And these are just a bunch of the scheduler that we have. We have synchronous scheduler, we have asynchronous scheduler using request animation frame, using different kind of asynchronicity, and we go even one step forward. They went one step forward with the concept of virtual time. RxJS is pretty powerful if you need to do something with time. But think about testing. You don't really want to wait the real time. And so you can plug in a virtual time scheduler that regulates how the event flow between each other. And that's really powerful. So last part, all for one and one for all. Big table. From the left-hand side top, MobX, paradigm, we learned that is transparent reactive programming, but we learned that those are not words. It's transparent because we are not in control of the subscription. The library is taking care of that. RxJS, event stream functional reactive programming. Why event streams? I don't have to explain you. Those are, well, all streams. Those were all events flowing to my all operators, chaining within each others. Execution. In MobX, the execution is synchronous because we wanted predictability. We wanted to understand how to change my state. In RxJS, it's sync by default, but it gives you the power to go async, to go crazy with virtual time, to do as many things as you want to do. Syntax, MobX.js is plain JavaScript, RxJS as library specific, but there is a start there. It's library specific now. We're going to see how that plays out in 1 year time. And observable. This is slightly different from what we saw so far. MobX is taking care about values. Why values? Because MobX is born, if you remember the first slide, is born with the idea of building a state management system. A state, your state matters, your state cares about values. So MobX is all about observable values. For example, in MobX, if you want to emit twice the same values, you can't do that because your state is about values, and it shouldn't be a concept, there shouldn't be a concept of time in your state, but we're gonna see that. In RxJS, instead, we are talking about events, not only values, but events, something that I can trigger. I can trigger in synchronous way, I can trigger very often, I can trigger once in a while, could be a mouse click, could be a scrolling wheel. So it's all about events and values as well, but mostly events, while MobX, only values. Why should I use MobX? First of all, learning curve. I don't have to tell you that if I don't need to explain you the syntax, you already have an advantage over another solution. You may have the little bit of, you may be worried about, well, inside the auto run there is some magic going on, but you can write it in 5 seconds and understand what's going on. With RxJS, I can't tell you exactly the same thing. Values, not event. Again, I want to stress out that MobX is for state management system. So your state is represented by values. This is a representation of the application state. We already said that. And last but not least, if this applies to your code and to your application, then probably MobX is going to be your next friend. If your state is just a derivation of the previous state, and bear in mind that I said previous state, not history of your previous status. If this is true, have a look at MobX, could help you out really well. When should I use RxJS? If we care about events and values. If we care about events and values, MobX gives us the granularity and the power to handle both of them. If you need to work with time, as we saw with the virtual time scheduler, or since the example is the example that I made about emitting the same event after a certain amount of time in RxJS is like bread and butter, like perfect. And then low-level control. I can't stress that enough, that you have a level of granularity that is not as near at MobX. So they are two different things, and they try to solve two different problems. And RxJS should come in play when you need to think about how asynchronous I want my code to be run. And that's something quite low level, because you usually say, well, it's synchronous or asynchronous, someone will call that callback later. You don't care about, okay, what does that mean later? If you're asking yourself that question, that's the answer. Can I use both? The answer is yes. Why and when can I use both? So imagine that RxJS handles an heavy task, or a task that is that needs very fine and granular control. Imagine classic example, if I don't know, if you wanted to throttle a scroll, or if you want to take control of multiple animations at the same time based on that. Imagine you have an heavy task. RxJS can do that, can handle that, and then it could tell MobX, look, I have a new value after everything that RxJS has to do. When you jump from Rx to MobX, you are starting to working on the application state. So you manage your animation, then once you're done, Rx is telling MobX, look, this is the new value for your application state. Your user has now 300 followers. And once you do that, you get the reaction that, for example, the view is updated. And this is a perfect flow to keep your application under MobX and to have RxJS handle the heavy part. This is a classic example of the company where I work, the Zone, live sports streaming company. We use MobX for the state management system, and we do have some RxJS for handling some part of the application. In this case, the small animation that you see has quite a few things that you may or may not notice. First of all, there is an overlay that goes one-to-one with the amount of pixels that you scroll, so it gets darker as soon as you go up. Then we are lowering the volume. Then we are calculating the height of all the rail. We are doing that animation. Doing that with MobX is possible. I'm not going to say no. But doing that with RxJS, it's 6 lines of code. And it's very comprehensive, and it's very, I would say, more maintainable, because our code should be about maintainability. So in our case, we are handling application state with MobX, and we have our scroll-based animation with RxJS. Last slide. This is mostly going to be in the slide, but if you found something interesting in this topic, in this talk, I would suggest you to read more about RxJS, to read more about transparent reactive programming. These are all links, so I will provide the slide and you can click on that. Transparent functional reactive programming, the discussion, that's really interesting. MobX, auto-run, have a look. There is really a bunch of cool stuff there. And that was the last slide. Thank you very much.
Thank you, Max. Thank you for the great talk.